Welcome back to my channel. In the previous video, you learned about color as a physical property of minerals. Today, we will learn about the hardness of minerals and how it is measured. Hardness is determined by scratching the mineral with a mineral or substance of known hardness. Hardness is a relative scale. Thus, to determine a mineral's hardness, you must determine that a substance with a hardness greater than the mineral does indeed scratch the unknown mineral, and that the unknown mineral scratches a known mineral of lesser hardness. Hardness of common objects. Fingernail 2.5, copper coin 3.5, glass 5.5, steel file 6.5. What is Mohs Hardness Scale? The Mohs Hardness Scale, developed by the German mineralogist Friedrich Mohs in 1812, is a relative scale used to measure the hardness of minerals. It ranks minerals based on their ability to scratch one another from the softest to the hardest. Catchy mnemonic for the Mohs Hardness Scale. Tall girls can flirt and other queer things can do. Each word stands for a mineral in order. T for talc, G for gypsum, C for calcite, F for fluorite, A for apatite, O for orthoclase, Q for quartz, T for topaz, C for corundum, D for diamond. On the Mohs Hardness Scale, minerals can be classified into oxides and silicates. Let's start with oxides. A key example is corundum, which has a hardness of 9 on the Mohs scale. Corundum is an oxide of aluminum. This mineral includes precious varieties like sapphires and rubies. Next, we have silicates, which are the most abundant group of minerals in the Earth's crust. Here are some notable examples. Talc, known as the softest mineral, talc is a silicate that contains magnesium, silicon, and oxygen. It's commonly used in talcum powder. Orthoclase. This mineral is a type of feldspar that contains potassium, aluminum, silicon, and oxygen. It's often found in granite. Quartz. One of the most well-known minerals, quartz is composed of pure silicon dioxide. It's prevalent in many geological settings and has a wide range of uses, from jewelry to industrial applications. Non-silicates and non-oxides. Now, let's explore non-silicates and non-oxides. Here are some key minerals in this category. Gypsum, a sulfate mineral. Gypsum is used in plaster and drywall. Calcite, this carbonate mineral, and is a major component of limestone and marble. Fluorite, a halide mineral. Fluorite is known for its colorful fluorescence under UV light. Apatite, a phosphate mineral. Apatite is important for both fertilizers and as a gemstone. Topaz. Although it contains silicate, aluminum, and fluorine, topaz is not purely classified as a silicate. It's a popular gemstone known for its hardness and variety of colors. Finally, we have diamond, the hardest natural substance on Earth with a hardness of 10. Composed of pure carbon, diamonds are prized not only for their beauty but also for their industrial applications. Several precautions are necessary for performing the hardness test. If you attempt to scratch a soft mineral on the surface of a harder mineral, some of the softer substance may leave a mark of fine powder on the harder mineral. This should not be mistaken for a scratch on the harder mineral. A powder will easily rub off, but a scratch will occur as a permanent indentation on the scratched mineral. Some minerals have surfaces that are altered to a different substance that may be softer than the original mineral. A scratch in this softer alteration product will not reflect the true hardness of the mineral. Always use a fresh surface to perform the hardness test. Sometimes the habit of the mineral will make a difference. For example, aggregates of minerals may break apart, leaving the impression that the mineral is soft. Or minerals that show fibrous or splintery habit may break easily into fibers or splinters. It is therefore wise to always perform the hardness test in reverse. If one mineral appears to scratch another mineral, make sure that the other mineral does not scratch the apparently harder mineral before you declare which of the minerals is harder. In some minerals, hardness is very dependent on direction, since hardness is a vectorial property. When there's significant difference in hardness in different directions, it can be a very diagnostic property of the mineral. It is thus wise to perform the hardness test by attempting to scratch the mineral in different directions. Two minerals of note have differences in hardness depending on direction. Kyanite has a hardness of 5 parallel to the length of the crystal, and a hardness of 7 when scratched along a direction perpendicular to the length. Calcite has a hardness of 3 for all surfaces except the 0001 plane. On 0001, it has a hardness of 2. Thank you so much for watching my YouTube video. I hope you found the information helpful and interesting. If you enjoyed it, please give it a thumbs up and don't forget to subscribe for more content. I appreciate your support and I look forward to seeing you in the next video.